Continuing with this idea of condensing logarithmic expressions, or taking two or more log expressions and putting them together so that you end up with one, let's take a look at this example here. So when we look, I said in the earlier video, first thing we want to do is put any exponents that are down in front as a coefficient back where they belong. So here, this 2 is an exponent, and there's nothing here that we need to take care of. So we have log x minus 3 squared, put that 2 back up where it belongs in the exponent, minus log x. So we have that expression now. And seeing this subtraction, that means we're going to have a division, which we represent as a fraction. So the x minus 3 squared goes in the numerator, and now this log x, the x, goes in the denominator. Whatever's behind the negative sign, the subtraction goes in the denominator. Notice we had two log statements. Once we combine using the property to make it a division, we only have one log statement, log. So you could leave it like this. If you wanted to put it in parentheses, you can. I'm going to leave it like this. Next example. We now have 3 log expressions. And if we take a look, that 1/4 represents an exponent that is down in the front. The 2 is also an exponent down in the front, as is the 10. So the first thing we have to do is put them all back in the exponents. So we have log base b x, and now that 1/4 goes up as an exponent. Continuing on, we have minus log base b 5, and that 2 now becomes the exponent. And then minus log base b y, and that 10 becomes the exponent. So we've put all the exponents back where they belong and cleared all the coefficients in front. I'm looking at this and I'm seeing this 5 squared here. 5 squared is 25. At some point, we're going to have to simplify that and make it 25. So I'm thinking, let's just do that now. So we have log base b x to the 1/4 minus log base b 25 minus log base b y to the 10. So there is our statement as of right now. There's 2 ways that you can go about doing this. I'm going to show kind of the longer way, and then I'll show another way. So we look here. We have this expression minus minus. So these represent divisions. This and this represents a division. One way to approach this would be to factor out the negative sign. So log base b x to the 1/4, and I'm going to factor out that negative sign. So negative, and now in parentheses, log b 25. Now this becomes a plus log b y to the 10. So to repeat, I factored out the negative, or negative 1. So negative log b 25 divided by negative that becomes positive inside the parentheses. Negative here, divide by the negative 1, becomes positive. Now we can see that these are joined by this addition sign, so we can combine them as a multiplication. So that brings us log base b, x to the 1/4, minus, and now I'm going to combine what's in the parentheses here. So notice we have 2 log statements. It's now going to be 1 log statement, log base b, and it's going to be the 25 times y to the 10. So it's going to look like that. Now, this subtraction says to have a division. We're going to have a fraction. So we have log base b, and now the x to the 1/4 is in the numerator, and in our denominator is this 25y to the 10. So notice we went from 2 log statements. Now we're down to 1. When we put the things together using multiplication or division, every time we do that, we jettison or throw away a log statement. So here is our answer, and we are going to tidy it up a bit. Log base b, and this x to the 1/4, I'm going to write in a radical. X with that 4 there to show the root is 4, and then the 25y to the 10 stays the same in the denominator. So that's one approach. Another approach would be from here, instead of factoring out the negative sign, we could consider this. We have log, let me just write it, b, x to the 1/4, and now we have minus log base b 25 minus log base b y to the 10. So we have this expression here. I just rewrote it from up there. Instead of factoring out the negative, one way you could think about this is this represents a division and a division. So this is in the numerator. And I had said earlier, anything after the subtraction is in the denominator. So I could make my statement log base b, and now the x to the 1/4 is in the numerator. This is after subtraction, so that goes in the denominator, and this is after subtraction. So this term here also goes in the denominator. And just similar to what we did up here, you can see these are the same answers. The last step would be to take this x to the 1/4 and write it as a radical, the 4th root of x, and then the 25y to the 10 stays in the denominator.